Whew, sorry about that. My allergies are killing me. All right. So, like I said, you're going to have a Docker file, make file, and obviously the README, the changelog. I'm not. I don't think we're really doing enough with the changelog yet, but it's good to have. It's good to start using once we get to a releasable state. So we're going to get to check out the Bootstrap directory tree for a second here. And inside the Bootstrap directory tree, you see a directory called Workspace. Now, inside of Workspace, you've got, it gets a little bit more complicated, right? Now, what I want to draw your attention to here is this exemplar.config. So this is how Foster uses exemplar. Exemplar is a tool that has three different types of JSON files that it ingests. One is its primary configuration file, which kind of sets the context for where it's working. It loads an environment variable file where you can set functions that are shared between what it executes. So if you're doing a lot of shell scripting, Exemplar is very useful for maintaining a consistent environment between those shell scripts, especially if you're doing a lot of bootstrapping into other environments. It also loads a plan file and a units file type. The plan file, if we go to plans, there's only ever one plan file for an exemplar build. And basically it says here are the tasks that you're going to execute and the order that you're going to execute them in. And it's got some basic dependency tree management where for each task you can say, so like here we do a bash version check, and that bash version check can depend on the logs being cleared, and it doesn't in this case, so we don't care. Now, binutils version check, we could technically set that to require the bash version check. You would just put the name as a string constant here for the dependencies, and then binutils version check would not execute unless this task had passed successfully. So there's a little bit of dependency tree management there. And then going to units. Units is a little more complicated. So Unix. So if you look in the plan here, you see all these tasks, but they're not really. It's not saying what these really are doing. It's just saying execute this task, right? Well, so units are where tasks are defined. A task doesn't. A task is a unit that's been added to a plan. And until it's added, it's just a generic unit. Like here's a thing that we can do. It's a definition for a task. So let's go here and let's look at some of our task definitions, which are units. So units have a pretty consistent format. You've got name, target, rectifier, active, required, rectify. And the name, okay, this is what we want to refer to it as. This is its identifier in the plan file. So when we go up, we say extract xcompiler binutils. That's going to be one of these. Extract, if I can find it. Yeah, see? And that's how we refer to that unit in the plan. So that's the name. The target is, this is the executable that I want you to trigger. And it'll go ahead and load whatever you defined for the variables file. There's a common variables file where you can set functions that are available in your environment or variables that are available in your environment for whatever you're executing in your units. So if I want to have Java home declared for all of my units, I can set it in one place there, and it'll be available to all of these. So that's what the target is. It's basically just the relative path from your root context to whatever you're executing. So it kind of forces you to have a very localized, self-supporting directory structure in your exemplar workspace. And that's all this is. That's all Foster is we're wrapping a Docker build around a Foster workspace. Or, I'm sorry, an exemplar workspace. Now, some of these have a rectifier. I don't think I've defined any of these for these early tests. But what the rectifier does is when you go to execute your target, let's say that fails, it'll return a non-zero execode. If that's the case, it'll go ahead and execute a heal script that you can set here. So let's say you want to install a package for your target. You could just really just do yum whatever install, and if that fails for whatever reason, you can have it do something else. Then it'll go ahead and retry the target. And basically what that means is that the rectifier's purpose here is to heal any conditions that would prevent the target from being successful. And we don't want to make the assumption that the heal needs to be run every time. We only want the heal to be run when the target fails. So it'll rectify the condition, the error condition. Then we've got some basic flow management here. You've got active, basically saying, do you want this to be able to be executed in a plan? If that's set to false, exemplar will not let you execute it in a plan. It'll halt the plan. And then the required attribute is basically saying, should I halt the plan if the rectifier fails or if the target fails and I don't have a rectifier set? If that's true, then it'll go ahead and halt the plan. Then the rectify attribute is going to say when you execute this unit, is it going to execute a rectifier script? If that's set to false, you can have something set here and it just won't run it. That kind of comes in handy with when you're troubleshooting. So we leave it there. So that's a units file. And the way exemplar works is you point it at a units directory. We want all of them defined in one directory. You can split it up into as many files as you want to load them all. You want to be weary of having too many files for your build, because then you can have some trouble tracking where your definitions are when you start to have to troubleshoot your units. Let's go back here. We also want to avoid duplicate unit definitions. It'll use whatever is defined last. So if you define one with a name of apples in download sources.units, and you define a task named apples in variable checks.units, it's going to use whichever file gets loaded last. So be careful with that. Okay. So that pretty much covers how Exemplar works. Exemplar is a really, really simple tool, but you can do a lot with it. So then we're going to go here, and we've got a Docker file. We're doing some black magic here with this. It's not really black magic, it's actually super simple. And then we've got our own snapshot of Fedora that we're using as our build system. Because we needed to have a consistent build environment between builds, and just running off of the default image for Fedora was not going to work for us. We certainly can later, as long as we take into account the fact that we need to version lock some of our packages for the package version checks. So we're going to go here, and this is all controlled by the makefile. Basically, it's just going to download the source code for Exemplar. That's this here. It'll download that source code. It will compile it inside the container, and then it's going to go ahead and oh, that's there. It's compiling, and then it's going to go ahead and start it up as a full container system. So that'll kind of give us some troubleshooting options. And what you're going to notice is that we have a shared directory here. Bootstrap workspace. And what that's going to do is it's going to, in fact, it's actually in the make file here. What that's going to do is share that local file system directory, Bootstrap, with the container at the root of the file system, so that we're able to execute inside of the Docker container while we're editing on the local file system. And that's actually kind of important because we don't want to have all of our editing restricted to inside the active container instance because we lose persistence in between generations, and we don't want to have that. We want to be able to do plenty of makes and not lose the changes that we've made. So the makefile is super simple, as you can see there. There's only two build targets. There's build and clean. So if we go into the control scripts here, let's check out build. Build is super simple. We're going to create a local image and mount that Bootstrap directory as a shared volume with the container image, or with the container instance. And then, let's see, that was build. Let's do clean. Clean is just, hey, I'm getting ready to make a commit, so you really want to be careful when you use that. But it's going to clean out your sources cache and any logs that you've created. And once we get to a point to where this is complete, you're going to have, once the build is done, you're going to end up with two files beside your logs directory. One is going to be your ISO file that gets generated. That's going to be a bootable Linux distribution ISO. And the other is going to be a Docker image, and that'll kind of give you a way to build a clean source. So let's go ahead and get started here. I think we've covered a lot of information there. So let's see what it looks like. So we're just gonna run make. It's this default target. It does ask you for the root password. There's a permissions issue with the logs because we're doing it as root inside the container and we're not locally. So that's relatively benign because it's all containerized in this directory. So here it does a little bit of cleanup on your local Docker environment. It'll delete any previous build attempts that you've done, and then go ahead and start the build. So in there, now it's downloading Exemplar. It's compiling it. It's done. And we are inside the container with a full shell going. Okay. Now, when it's time to execute this, we're going to go Exemplar. We want to point to our configuration file. See? It's everything that was in our workspace here.